Alright, what's up guys? So now we're looking at 8.3 areas of regular polygons. So in the last lesson you learned about something called an apothem and you learned about the radius. And so what we're going to do is we're going to use those two things to help us find the areas of regular polygons. So here we go. Alright, so let's go and get started here. So the first thing we're going to look at is exactly how to find the area of a regular polygon. So real quick, I want to let you know. Remember, regular polygon means all of the angles are congruent and all of the sides are congruent. So to find this, the area of a regular polygon is half the product of the apothem or the apothem and the perimeter. So if you look at this, this is going to be the formula. So A is equal to 1/2 A times P, which A is the apothem and P is the perimeter of the shape. Okay? So let's go and get started on the examples, and we're just going to delve into this. So look at example number 1. It says this regular hexagon has an apothem and a radii drawn. We need to find the measures of each one of these numbered angles. So let's go ahead and just look at this. This is going to help us to answer some questions here in the future. So the measure of angle 1, if I was to look, angle 1 is made up of a radius and a radius. These two lines right here are going right here. So if I kept drawing the radii going all the way across this, it would end up making 6 angles. And then all of those angles are going to add up to 360. So if I did 360 divided by 6, that would give me the measure of angle 1. So angle 1 is going to be 60 degrees. Okay? So now let's go ahead and look at angle 2. So the measure of angle 2, if I look, it's going to be cutting that angle in half. So basically the apothem is going to be cutting that angle in half. So angle 2 is going to equal 30 degrees. And then of course angle 3 is going to be the same thing as angle 1 because it's going to be basically that triangle is making a 30, 60, 90 triangle. So angle 3 is going to be 60 degrees. So now let's skip over and we're going to look at example number 2, and we're actually going to use our area formula next. Alright, so let's look at example number 2. So it says we need to find the perimeter and the area of the regular pentagon with the apothem of 2.1 inches and one side with a length of 3.1 inches. So right now, again, I want to point out regular polygon. Remember, that means all of the angles are congruent and all of the sides are congruent. So that means if one of these sides is 3.1 inches, that means all of those sides are going to be 3.1 inches. And then I'm going to go ahead and draw from the center, going straight down to one of my sides is going to be 2.1 inches as well. So let's go ahead and look at this. So first thing I need to find is the perimeter. I know the perimeter is basically all of the sides added together. So if I have a pentagon, that means I have 5 sides. So that means to find the perimeter, I'm going to take one of those sides, which is 3.1 inches, and I'm going to end up multiplying it by 5 because that's going to give me the perimeter. So 3.1 times 5 is going to end up giving me 15.5 inches. So that means the perimeter all the way around this pentagon is going to be 15.5 inches. So now, in order for me to find the area, I know to find the area, all I have to do is 1/2 the apothem times the perimeter. So let's go and plug everything in. So I'm going to do 1/2 the apothem is 2.1 inches and the perimeter is 15.5 inches. So if I actually multiplied all of this out, the area of my pentagon is going to be 16.275 inches, and remember, area is measured in square units, so it's going to be inches squared. So right here my perimeter is 15.5 inches. And my apothem or apothem is going to be 16.275 inches squared. Perfect. Okay, so now we're going to be looking at the same thing on number 3. So here we go. So on number 3 it says to find the perimeter and the area of the regular octagon. So remember, regular means all of the angles are congruent and all of the sides are congruent. So right here, my apothem is going to be 7.6 meters, and then my length of my side is going to be 6.3 meters. So I'm going to put 6.3 meters here. Okay? Alright, so first thing I need to find is the perimeter. So to find the perimeter, I know all I have to do is add up all the sides. So if all the sides are going to be 6.3, I have 8 sides, so I'm going to do 6.3, and I'm going to multiply that times 8 to get my perimeter. So 6.3 times 8 is going to end up giving me 50.4 inches, or is that meters? I think I'm using meters. Yep, meters long. Okay? And so with this being said, so my perimeter over here is going to be 50.4 meters. So now I'm going to take the perimeter and I'm going to take the apothem and I'm going to use that to find the area. So I know A is going to be equal to 1/2 the apothem times the perimeter. So let's go and plug in everything I know. So 1/2, my apothem is 6.3, and my perimeter is going to be 7.6, sorry, is going to be 50.4 meters long. So now all I have to do is multiply that all out, and my final area is going to be 191.52 meters squared. So that is going to be my area. So 191.52 meters squared. Alright, so let's go ahead and finish up and look on the back at examples 4 and 5. Alright, so on number 4, it says a regular hexagon has an area of 18 centimeters squared. If the apothem is 2.4 centimeters squared, we need to find the length of each side. So basically what we're going to do is we're going to take our area formula and we're going to work back to help me find the length of one side. So I know the area of a regular polygon is going to be 1/2 the apothem times the perimeter. So what I'm going to do is I'm going to plug everything in I know, then I'm going to solve for what's missing, and then I'm going to end up using something else to find the missing side. So I already know the A, which is the area, which is going to be 18 centimeters squared. Then I'm going to put in 1/2, and I know the apothem, which is 2.4 centimeters. And then I'm going to leave P as P because that's what I'm going to end up solving for. So what I'm going to do on the right side of my equation is I'm going to go ahead and multiply 1/2 and 2.4. So 1/2 of 2.4 is going to give me 1.2 times P. And since I'm multiplying here, now I'm going to end up dividing by 1.2. So 18 divided by 1.2 is going to be, the perimeter is going to equal 15. So my perimeter of my shape over here is going to equal 15. But it says it wants me to find the length of one side. So I know inside of a hexagon there are 6 sides. So now what I have to do is I have to take that perimeter, which is 15, and I have to divide it by the number of sides. So 15 divided by 6 is going to equal 2.5 centimeters. So ladies and gentlemen, one side of my hexagon here is going to equal 2.5 centimeters. Okay? Alright, and lastly on number 5, it says a library is in the shape of a regular octagon. Each side is 18 feet. The radius of the octagon is 23.5 feet. We need to find the area of the library. Okay, so first off, everything in this problem is going to be based off of the area of a regular polygon, which we know is 1/2 the apothem times the perimeter. So the first thing I can go and do is I can go ahead and find the perimeter of this because I know each side is going to be 18 feet. So to find the perimeter, I'm going to do 18 times the number of sides, which we're dealing with an octagon, so I'm going to multiply it times 8. So 18 times 8 is going to be 144 feet. So that means the perimeter of this is going to be 144 feet. So now if I look here at my octagon over here, if I look, the radius of my shape, this bottom side down here, and my apothem are making a right triangle. So I know I can use Pythagorean theorem here to find the apothem of my shape here. So I'm going to go ahead and do that. So down here in the bottom right, I'm going to do a squared plus b squared is equal to c squared. So right now I know my a value is going to be 9. Actually, I'm going to leave the a as the apothem. So the apothem is going to be a. My other side is going to be 9. And then my C value, which is going to be the hypotenuse of my right triangle, is going to be 23.5 feet squared. So now 9 times 9 is going to equal 81. So a squared plus 81 is going to be equal to 23.5 squared is going to be 552.25. And so now all I have to do is subtract 81. So a squared is going to be equal to 471.25. And then to get rid of the squared, I have to take the square root of both sides. So right now I'm just going to leave it as the squared. My apothem is going to be the square root of 471.25. So now, ladies and gentlemen, I have my apothem, I have my perimeter. So now all I have to do is go plug it into my equation up here and then find the area. So area is going to be equal to 1/2 the apothem, again, which is the square root of 471.25, times the perimeter, which is going to be 144. And so if I end up multiplying all this out and working it out, the area of my octagon, or my library per se, is going to be 1,562.997 feet squared. So ladies and gentlemen, we have just now used some things in the past that we used before and use now to find the area of a regular octagon. Now let's switch over and go to our practice.